Hello YouTube and welcome back to the channel. Welcome back to Classically Vibrant. Today we're going to be diving back into our permaculture series, and we're going to have ourselves a little lecture on chapter 2 of Bill Mollison's Designer's Manual. And chapter 2 is entitled Concepts and Themes in Design. So today we're going to be getting into more of the nitty-gritty of actual design principles and how they mesh together to create a functional permaculture site or permaculture design. More so the basic principles though. We're not going to get too intricate or too detailed with different permaculture techniques and practices. Simply, we're going to be talking more about the general design principles today. And in the prior chapter, the prior video lecture I did, we discussed the ethical basis of permaculture. We also defined what permaculture exactly is, and we also talked about what permaculture seeks to ultimately do. So before we dive into chapter 2 today, let's just remind ourselves a little bit about what we talked about in our previous lecture. So we define permaculture as a design system that acknowledges certain natural principles and then takes those principles and applies them to like conscious and smart design of communal infrastructure. And following from that definition, what permaculture seeks or aims to do is to bring us as a society, as a culture, back into a state of communal permanence, where we are not as separated from the surrounding natural environment. And today, what we're going to be looking at is the different concepts and themes unique to permaculture design. Whereas before, like I just said, we had strictly examined the philosophy and reasoning behind permaculture. We had also highlighted a very important principle in the prior video lecture that I heavily emphasized, since it will be coming up again and again in all of our subsequent video lectures. And this was the principle of cooperation, which, like I said, it'll continue to be the underlying principle that directs the overall structure of each individual theme and design concept. And all universal life systems, all natural systems, that I'm talking now outside of the scope of permaculture, they all use this principle of cooperation. They all cooperate in a way that allows for both the creation and preservation of the right conditions that make life possible in the first place. So the principle of cooperation is seen to be working on every level of nature, and the permaculture designer both realizes and understands this, and they take this important principle and make sure that it is ultimately governing every single other design principle inside of one of their sites or projects. And the principle of cooperation is flexible, and it actively adjusts to regulate any sort of environmental disturbances. However, if humanity doesn't recognize or remember this principle soon enough and apply it to the smart design of our infrastructure moving forward, then we will inevitably become the one disturbance that our Earth can no longer tolerate. And one more thing to mention was the ethical basis that we'd gone over in our first chapter. So we'll be talking about different tenets or different principles, individual principles of design in our lecture today, but we also had gone over the individual tenets of the ethics of permaculture in our prior chapter. And those free individual tenets, to remind us what they were first, the care of the earth, second, care of people, and thirdly, the setting of limits to both our population and our consumption. We had also discussed the principle, I already said that, we discussed the principle of cooperation in our prior lecture too, that I had just gone over, and how permaculture uses this as it strives to bring us back to a state of communal permanence. Without permanent agriculture, or permaculture as we've coined the term, there is no possibility of a stable social order. Thus, as we see nowadays, the move from permanent productive systems, where the land is held in common, to annual commercial agricultures where land is regarded only as a commodity. The further we depart from communal permanence, the greater the risk of things such as tyranny, feudalism, and revolution, and the more work we have to put in for lesser yield. So a departure from communal permanence, it involves a departure from a low energy to a high energy society. And a low energy society being one that uses, very minimal amount of resources in order to keep things running smoothly and keep yields of certain foods or materials at a fairly high end, but not with with the requirement of large amounts of energy resources. So that would be like a permaculture type of site project, municipality, city, town, or society. That's what permaculture or communal type of infrastructure would look like. It would be a low energy one. It'd be very self-managing, self-regulating. There wouldn't be a lot of energy input required for that to run smoothly. Whereas in a high energy society, like the big cities, towns, and certain countries or areas of the world, they would be considered a high energy society. You could use Chicago as an example. Chicago would be considered a high energy society, and these types of high energy societies, they use land in an exploitative way, and demand for external energy resources, mainly provided by the third world or third world countries. So they take a lot in, a lot of food, oil, and other resources, but they don't properly direct that energy back, or they use a lot of it and there's a very minimal yield from all that energy being funneled in. And had we taught this approach of permaculture design, permaculture infrastructure from the beginning, we would all be living in a much more stable and functional landscape. But our grandparents failed us in that regard, and perhaps we're continuing, perhaps we're using the same sort of blueprints and thinking for infrastructure moving forward, since we turned into an industrialized nation and an industrialized world. It's the reason for continuing to have misdesigned households, houses that face the street instead of the sun, or in a larger sense, misdesigned towns and cities and municipalities. So yeah, perverse planning, it's obvious everywhere. Houses don't face the sun, but instead they face the road. Lawns replace gardens. We should have gardens instead of lawns. It's really weird. going around and you have all these professionally manicured lawns and landscapes, but you can't see a single food crop on them. There's no, where are your pear and apple trees? Where's your grapevines? Where are your mushrooms and maybe chickens or whatever? Those aren't present in the average on the average property front. And there's trees to be are planted only to be pruned and tended, nothing else, just for looks, purely for aesthetic reasons. But permaculture is obviously more than landscaping. It is functional landscaping. It is both aesthetically appealing, and it serves a greater functional purpose to the residents that reside in a permaculture site or permaculture community. When we left tribal life, we left with it all guides to sensible behavior in the natural world, of which we are a part of and in which we live and die. So yeah, when we were more of a primitive people, we hadn't developed yet into these very grand civilizations and cities. We lived a more tribal existence, and because of that, we were inextricably and unavoidably linked to our surrounding natural environment. And so we had a very intuitive sense about different principles that govern the natural world and how we fit and relate to that frame or to that framework. And so it doesn't have to be that, having developed sophisticated architecture or buildings, sophisticated man-made technologies, they don't have to be opposed to the natural world. They can work in tandem with it. And so permaculture combines kind of the best of both worlds, the industrialized and technologically advanced part of our species, and the tribal and communal part of our species, which is best for our health and the health of our planet. So combining the two is kind of what permaculture is, that focal point between the two. And so yeah, because we have replaced nature-based nature-based religions, mythologies, with a set of fixed prohibitions relating only to people and totally unrelated to nature whatsoever, just prohibitions regarding our behavior and our being, we have developed this very destructive and people-centered or anthropocentric religions and civilizations. And when I read this particular, when I took this from the book, I took this verbatim from the book as part of my notes, my compiled notes for this lecture. When I was reading this particular part of the passage in the chapter, a certain thought popped into my mind, and it was regarding a philosophical concept. And this philosophical concept talks about the nature of God. And it's about two different lenses, or two different ways of seeing the nature of God. The one being of transcendence, and the other being of immanence. So like nature-based mythologies, they would revere nature, but because of that, God was, they took a more immanent view as far as regarding God. So immanence meaning that God is solely a part of our physical existence. He's in every single blade of grass, tree, animal, human being, molecule, so on and so forth. And he's simply part of the totality of our existence here. So nature-based religions, I can't really think of any tribal ones, because those are very particular and specialized, and probably very ancient, and you can't really remember every single one. I'd have to do my research on that. But As far as the big ones, we tend to think of Eastern religions as being most nature-based, and those would be like Taoism, Buddhism, Hinduism, just to name the big three in my mind. And they tend to not side with one or the other view. I think they share both. They see God as an immanent reality and a transcendent one. But when we talk about our anthropocentric religions, those that place the human being as, or glorify the human being as the ultimate end of creation and the one thing that should be cared about and dignified, these would be your religions such as Christianity, Islam, and Judaism. They see the natural world or the rest of the creative order as simply a means to an end, or simply as a servant to humanity to keep them alive long enough to worship a transcendent God, because they feel like it doesn't really matter how we treat. I'm not saying this is as like I'm not saying all people in a religion have this sort of view, but I'm just talking generally speaking. They see the natural world as something that is allowed to be exploited if it means that the dignity of the human being is maintained and upkept long enough that they may find God. And so they tend to have a transcendent view of God. So a view that says God does not reside here at all. He's entirely removed from that equation. He's residing in a totally transcendental realm, totally separated from this physical realm, totally, utterly worldly and indescribable. And yeah, so those are like the two views that popped in my head when I was reading that specific part of the passage. And that it's dangerous to adopt either one of those views, but it's even more dangerous to adopt only the transcendental view, because then you'll tend to abuse and not respect the rest of creation if you feel that God is not really present in it, right? And yeah, like I was saying before, this is kind of a blanket statement I'm making. I mean, when we adopt either one of those views, you might end up like we just said, with very very destructive and people-centered civilizations and religions as a result. So what Bill's book really emphasizes, or it emphasizes self-reliance, responsibility, and the functions of living things. Within a self-regulated system on Earth, energy from the sun can be trapped and stored in any number of ways. So in both life and in design, we must accept that immutable rules will not apply, instead be prepared to be guided on our continuing exploration of these flexible principles and directives that govern the overall design of a permaculture site. So say you're like a scientist, maybe if you're a theoretical scientist, and you understand certain scientific laws and equations and how they work in different scientific models, but when you go out into the real world and you apply these same laws or equations, they don't pan out exactly the same as they do in the models. There has to be some adjusting to be made in order to account for things, or you have to account for certain things in real life in order for the laws to hold. It was the same with permaculture. These rules are not set in stone. They can be changed if need be, to account for new circumstances that were not foreseen prior to drawing up a design or prior to interacting with a particular site. And so the role of a successful design at the end of the day, the role of a successful design is to create a self-managed system, a self-regulating system that doesn't require a constant upkeep and input of the residents on that site. From this follows a policy of responsibility, and that is to relinquish power to re-empower ourselves. That's really also the final job of a permaculture designer. It's to be a beneficial authority, and how Bill defines a beneficial authority is one who is able to return function and responsibility to life, and to both to life and to people. If successful, no further authority is needed after that. If everyone is self-functioning, self-sustaining, and life around them is doing the same, there's no need for intricate governments and rules and social orders when everything is in the place that it should be. So a group of people or a group of scientists, whenever they're first tackling a problem, they usually have a different set of steps or series of steps to help them solve that problem. And the same goes with permaculture designers or a team of permaculture designers. And Bill gives us 10 different steps that help with that process. So this is not the design principles just yet, but this is something to consider before a design process is initiated. And you've identified certain problems that need to be addressed on a site. And so the first step he talks about is that of improving tools or inventing new tools for specific jobs. So if you feel that there's a problem on a site that needs a specific tool that either you don't have or no one has, then it's important to either create a new tool or improve on existing tools. Second step would be to collect a large set of observations and occurrences or samples of a set of phenomena, and then sort them on the basis of their likeness and their uniqueness. So on their similarities and on their differences. That's something you would do in order to better help you classify different things going on in an environment or an ecology, and then you're better able to designate them to a certain area or a certain function. And the third step then would be insight. Insight as in the aha moment or eureka response to observation. You observe certain things happening and you say, that's what that means, or this is where this could fit. The fourth step would be trials, and this is the type of step where you say, I'm going to give it a try and see if it works. The fifth step would be guessing. And guessing is done based on trials that are already known to have worked. And this allows, if you can't figure out how to make certain adjustments on a site, guessing would be the fifth step. 6 would be to observe unique events and take note of them. The 7th would be accidents, which are trials set up for one reason, which means that when you set up a trial for one reason to see if X will happen, what ends up happening instead is Y, so something unpredictable happens. And so, things are made for one reason and then they end up being applied for a totally different reason because they're observed to work in a totally different way than expected. The eighth step would be imitation. And by testing, this is by testing already known effects previously discovered by others. So you're taking something someone might have used as a solution to one problem, and you say, hey, I have a similar problem, or I have a similar design problem. I'm going to use what they did, see if that works. 9 would be patterning. Patterning is seeing a pattern to events of often very different natures, and thus producing insights into underlying effects. And the last step, number 10, is common sense. Common sense is often called management in permaculture, or in business and natural systems control. And this consists of staying with and steering a system or enterprise for constant adjustment to a successful conclusion or result. So no matter what happens, using common sense and being able to finally direct a project to the desired end result or conclusion. Now, so we're going to dive into certain principles now of permaculture. And principles, they're different from dogmas in that there are no penalties for error. You're not going to get a slap on the wrist or get your head chopped off or go to jail or whatever for not complying with certain principles or breaking certain natural rules. But you're only going to learn from that. You're only going to learn from your error and your mistakes, which leads to an evolution, to a new evolution. And before we get into the principles, 6 principles I'm going to espouse of natural systems, I'd like to talk about our diagram up here on the board. And I have 2 separate piles of notes. So the second pile is specifically for this diagram. And what this diagram has is looking at here is the proper setup of an energy efficient system. So we were talking about low energy and high energy societies in the beginning of the video, or more specifically now, low energy versus high energy designs. And a designer's work is to set up a useful energy storages in a landscape or building. And these sort of storages, they're available for increasing yields, and what they're named in permaculture terminology are resources. These storages are known as resources. And so a couple principles that are demonstrated or displayed here are first the life intervention principle, which says that in chaos lies unparalleled opportunity for imposing a creative order. So one person might see, a type of ecology or site, and they say, oh, this is very chaotic and unstructured, even though it's working and performing perfectly fine and okay inside the framework of natural principles. But it's also ripe for imposing your own creative order onto it so that it benefits you as well, but doesn't detract from what's already there. So it's not exploitated, but it's simply worked with. It's observed first, and then the design is imposed upon it to get the most beneficial relationship out of it between you and your people and that landscape. And the second principle is the law of return. And what the law of return says is that whatever we take, we must return. Or another way to put it is that nature demands a return for every gift received, or the user must pay. So however you're using your natural environment, to take that into account and see what must be replaced or replenished in order for that to happen again over and over into the future. So like I said, every object must be responsibly provided for its replacement, and society must, as a condition of use, replace an equal or greater resource than that which was used. So in the two pictures here in this diagram, we have state A of a valley and a lake, and state B of a valley and a lake. In state A, nothing has been done yet to this particular site. Simply, it's a topographical picture of the site of the valley. You have these different lines demarcating each level of the valley, and then you have the lake at the bottom. And in each different state, you have a source of energy. In this case, it would be water running down through the valley, and you have the sink being the lake at the bottom of the valley. And two different depictions of the source to sink relationship here is one, the source simply flows all the way down to the sink, and it's not used in any sort of particular way. It's just doing what it would naturally do. And then in state B, we have a little zigzag here to each, like I mentioned before, resource or a storage unit. So the water goes from resource to resource to resource to resource before it hits the sink, and energy is utilized in the best way possible by the designer who placed those storages strategically. And so we design to catch and store as much water as possible from the hills in this scenario before it ends up at its sink in the quiet valley lake. If we made no attempt to store it, if we didn't do that at all, or use it as it passes through our system, we would suffer drought, right? We wouldn't have any water to use. Or we'd have to import it. We'd have to import it from outside our system or use energy to pump it back uphill. This is very energy inefficient, very energy costly. Whereas you see, a smart designer sees this beautiful opportunity, water running down into a valley, and they say, all right, how are we going to best design it so that it's most advantageous both to us and to the health of the overall valley. So on the local level, cities appear to be, like with the diagram here, an open energy system. They appear to be open, but they return very little energy to the systems that supply them. So there's no feedback back to the original source of that energy. It's just a constant drain on the source. And they pass on, cities will afterwards, they pass on all their wastes as pollutants to the sea. They are not in an exchange, but instead they're in a localized one-way trade, a very parasitic trade with respect to their food source. All cities, they break this basic principle. They break the law of return. And I kind of jokingly say that cities are kind of like big dense pimples on our maps where everything, mainly food, all food funnels into them, and then all that food just flows through the very intricate sewage systems we have going on in the cities, and then that ultimately ends up in whatever is the nearest body of water, whether that be a lake or sea or ocean, whatever. And that's one thing. As we move along the chapter, we're going to be discussing different waste management systems, but I always found, the sewage system to be very perplexing concept, very weird, very weird and bizarre. Like, why would you be funneling all that waste directly out to the sea when you can reuse it and it can be in a less smelly manner? Composting waste, or composting human waste is much less smelly than the sewage route. The sewage route smell can't really be nothing can really be done about the smell when you just have your urine and your waste just kind of sitting stagnant in the body of water. That's besides the point, though. That was just to demonstrate that cities appear to be open energy systems, but in reality they're the opposite of that. So yeah, like I was talking about in our valley scenario, the strategy is to set up an interception net from the source of energy to the sink, and then this net is a compound of both life and technologies, or a compound of a web of life and technologies. And all energy that enters an organism, population, or ecosystem can be accounted for as energy which is stored or leaves. Energy can be transferred from one form to another, but it cannot disappear or be destroyed or created. No energy conversion system is ever completely efficient. So, having covered what a proper energy conversion system would look like in a permaculture site, now we're going to move on to different design principles more specifically. Right now we're going to be talking about more specifically principles of natural systems, 6 to be exact. So I'm going to write those up on the board and explain them a little bit. So, first principle is that nothing in nature grows forever. There's constant cycle of decay and rebirth. Continuation of life. You know what, it might take me too long to write them all up on the board. I forgot that they're a little more lengthier in their description, so I'm just going to talk about them. I think that'll be a better use of our time here in this video. It's already running kind of long. I'm not going to go past an hour, so. So yeah, the first natural principle of principle of a natural system is that nothing in nature grows forever. There's always a constant cycle of both decay and rebirth. Nothing is a constant in nature. It's there one day and gone the next, or it's transformed into something else. 2 is that the continuation of life, it depends on the maintenance of the global geochemical cycles of essential elements. So the overall health and the continuance of life on this planet depends on this soup, this biogeochemical soup, and the proper ratios of them, making sure they're always cycling. And these particular ones are carbon, oxygen, nitrogen, sulfur, and phosphorus. So these always need to be cycled properly in order for life to be at its most strong and abundant and healthiest. So yeah, we need to be able to cycle these and other minor nutrients, not just those 5 I mentioned, to stimulate growth and to keep the atmosphere and waters of the earth unpolluted and clear. Third natural system principle is that the probability of extinction of a population or a species, it's greatest when the density is very high or very low. So when the density of a particular species is very high, this means that extinction is, somewhere on the rise or somewhere over the horizon. And the same goes if a population density is very low, if there's not a lot of the species left, then extinction is also on the brink or on the horizon. Fourth natural system principle is that the chance that species have to survive and reproduce is entirely dependent primarily, I should say, upon 1 or 2 key factors in the complex web of relations of the organism to its environment. Fifth principle is that our ability to change the face of the earth increases at a faster and faster rate than our ability to foresee the consequence of such change. So yeah, before we know what we've done or what we're doing, we have already overshot, our foresight into what will be the consequences of our actions, and before you know it, we're in the middle of those consequences. Hence the folly, the mistake of destroying life systems, destroying natural systems, just for short-term profit, just as regarding land as purely as a commodity, has far-reaching detrimental consequences for both the people in power and both those under their power. Both parties are going to suffer from those types of ill-informed actions. Sixth natural system principle is that living organisms are not only means but ends. In addition to their instrumental value, so this is talking about a permaculture designer has to see every single organism on a site and think about what sort of value they're going to add to the site, what sort of function they're going to bring to the site. But besides that, this is almost like an ethical principle, because it says that in addition to their instrumental value to humans and other living organisms, they have an intrinsic worth. They're valuable just as they are. This is the life ethic. This is the sort of life ethic that is often missing. It's often missing from otherwise very ethical systems. So, some practical design observations that we should observe is that, for one, the systems that we end up constructing should last as long as possible. I mean, we have the word perma in permaculture. It means permanent. It means, these systems that we're trying to design here are meant to last for as long as the sun is around. So, and they should also take the least amount of maintenance. They're supposed to be very self-regulatory and self-managed if designed well enough. And these systems, which are fueled by the sun, should produce not only their own needs, but the needs of the people creating or controlling them. So it shouldn't be just, if it was only providing for its own needs, then it would just be like any other sort of natural environment or ecology. It wouldn't be a permaculture site. What makes it a permaculture site is that it's also meeting the needs of the people who created or controlled that system, or who designed that system. Thus, they are sustainable, as they sustain both themselves and those who construct them. So we can use energy to construct these systems, providing that in their lifetime they store or conserve more energy. They store or conserve more energy than we use to construct them or to maintain them. They're a low energy system. They output more energy than initially was inserted into the system. So now moving on, we're going to talk about now the design principles that Bill had distilled for us for use in permaculture. And this is also going to be 5 separate principles. I'm not going to write them on the board again, I'm just going to speak about them. And the first design principle to acknowledge as a permaculture designer is that you should be working with nature rather than against it, right? So that's why it's really important to understand the 6 principles I just mentioned that have to deal with natural systems, because this is the framework you're going to be working within, and you have to use it to the flow of your system rather than try and force something out of it, when that would only end up being an impediment to the overall flow and operation and function of your system. Number 2 is that the problem is usually the solution. The problem is the solution. Everything is a positive resource. So maybe you might see, like a pile of rocks in your system or in your site, and you might say, man, this has no use. This is just getting in the way of what I'm trying to do or how I'm trying to design a system. It shouldn't be the way you look at it. Instead, you should look at, this large amount of stone or rock or whatever the case may be, whatever it is, and give it a use or give it a function in the system. The third principle is that you should make the least change for the greatest possible effect. So you don't have to go crazy when you're making a design. You don't have to totally uproot, totally fashion some kind of, this isn't like a construction project. It is a construction project where you do have to do some construction work, but it should be kept to a minimal if possible. You're trying to do the least amount of things for the greatest possible effect. Number 4 is that the yield of a system is theoretically unlimited. You can always add more to a system than you might have thought at first. Like if you think you have fully planted an area, for example, almost any other innovative designer, they can see ways to add something else. They can see ways maybe to add a vine there, or maybe a fungus or some sort of beneficial insect. Or they can see a yield potential that has just been ignored completely. They might see something that you might have overlooked. So you can make a very, very high yield, highly energy efficient system. The sky's the limit with that. And the 5th design principle, is that everything gardens, or everything makes its own garden. And this is just a way of saying that everything has an effect on its environment. So, for example, if we look at a rabbit will make burrows, and it will make defecation mounds. It'll scratch out roots, create the conditions favorable for weeds to grow, such as thistles. And maybe if we look at another example, we could look at people. What sort of effect do people have on their environment? People build houses, they dispose of sewage, they dig up soils for gardens, and they maintain annual vegetable patches. So this is the sort of effect human might have on their environment. So yeah, everything has an effect on its environment, and it's something you have to consider as a permaculture designer. And so, like, if you were talking about this last principle, that everything gardens, you see that a rabbit has these number of effects on its environment, and then you can use the rabbit accordingly. You can use it directly either as food, eat the rabbit if you so choose to do, or you can help it, and you can use to help it in fire control. You can use to have it prepare soil for thistles if you want thistles to grow, and a rabbit is good at creating the correct soil conditions for thistles to grow. Then you would use it in that manner. Or maybe you wanted to grow something more edible, like cardoons and artichokes. A rabbit can make the right soil conditions for those types of plants too. And it also, you can also use it maybe to shelter many native animal species in their abandoned burrows. So there's a lot of native animal species in the type of ecology you're working with, and rabbits are very good, they're very efficient at creating burrows. Then you take that into account and you say, okay, I'm going to have rabbits here because there's a lot of species that could benefit from having rabbits around, with an increase in the amount of burrows that are being produced. So yeah, what we covered today, basically we looked at 6 principles as they relate to natural systems. What are the 6 principles that relate to natural systems? And we also looked at the 5 main principles that a designer has to work with when drawing up any sort of design. If I could sum up this lecture in 1 sentence or 2 sentences. And our next lecture, we're going to be, since this chapter is a little bit more lengthier, I'm deciding to split up this chapter into maybe 2 or 3 parts. Today we just looked at different concepts and themes, principles of design and principles of natural systems, and we also talked a little bit in the beginning about what we talked in chapter 1. I'm going to break it up into 2 or 3 parts. The next part is going to talk about yields, resources, and food webs in a design. And then the third one, I'm not entirely sure. I have to get to the end of the chapter to see what the third video is going to be on. I might just make a second video if I think I can fit everything into one video, but we'll see. So yeah, thank you for tuning in and listening to this second lecture on chapter 2 of Bill Mollison's Designer's Manual. And I'll catch you all in the next video, whether that be next video in our permaculture series, or whether that'll be video on some sort of other topic or concept. So far I've only made 1 video as regarding a spiritual concept, so I might make another video associated with that, or I might just continue on with our series. So yeah, thank you all for watching, and have a wonderful day.